The James Webb Space Telescope is about to begin investigating astounding light shows happening on one of the giants of the solar system, Uranus. These mysterious lights have been puzzling scientists for a long time, and for a good reason. The main goal of the $10 billion space telescope will be to explore in greater detail the processes creating polar light shows over different planets. Auroras are familiar to people on Earth. We have stunning northern and southern lights, which can be observed along the poles of our planet. They're generated when charged particles streaming from the sun's solar wind hit our planet's protective magnetic field called the magnetosphere. These particles then travel down magnetic field lines and interact with particles in the atmosphere of our planet, creating glowing lights. Auroras have been spotted over other planets in the solar system before. Theoretically, they should be able to occur around any planet with an atmosphere and magnetic field. However, not much is known about extraterrestrial light shows. Currently, we know very little about auroras on Uranus. This is an ice giant with an atmosphere that consists of water, ammonia, and methane. It was just last year, after 3 decades of investigation, that a research team confirmed an infrared aurora around Uranus. Due to a collision with a roughly Earth-sized space body that occurred in the past, Uranus is tilted at a 97.77-degree angle. In other words, its poles are oriented almost directly toward and away from the Sun, and its auroras are positioned around the area that would normally be the equator for any other planet in the solar system. Along with observing auroras on Uranus, researchers will also try to find the answer to an intriguing question. Are auroras responsible for keeping this icy planet warmer than expected? The temperatures of all the gas giant planets in the solar system, including Uranus, are hundreds of degrees above what they should be if these planets were only warmed by the sun. The big question is, what makes these worlds so much hotter than expected? One theory suggests that auroras could be the reason. They could generate heat and push it down toward the magnetic equator. James Webb is supposed to start its study of Uranus early in 2025. The telescope is going to capture images of the ice giant over a single planet's day. It lasts around 17 Earth hours. Hopefully, it will allow the research team to map auroras across a whole rotation of the magnetic field of the planet. Scientists also want to find out whether Uranian auroral emissions are produced when the magnetic field of the planet interacts with the solar wind, as it happens on Earth. Another theory states that charged particles might be coming from sources within the planet, similar to how Jupiter produces its auroras. On the largest planet in the solar system, charged particles trapped in the magnetic field around the planet spiral inward toward the north and south magnetic poles, producing auroras. Another aurora researching project involves gas giant Saturn. Astronomers are going to observe this planet's northern auroral region for an entire Saturnian day, which lasts 10.6 Earth hours. This will allow the team to monitor how the temperature in that region changes as Saturn rotates. By examining Saturn's atmospheric auroral energies for the first time, experts hope to find out more about the sources of charged particles driving the planet's auroras. Some of Saturn's auroras might be caused by swirling winds within the planet's atmosphere. This previously unknown mechanism of triggering atmospheric light shows hasn't been seen on any other planet before. Saturn is actually one of the windiest planets in the solar system, with wind speeds reaching almost 1,120 miles per hour near the equator. These powerful winds seem to be responsible for the planet's variable rotation rate, which makes it difficult for astronomers to figure out how long the day lasts on the ringed planet.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. it has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's Infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1, and recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
What is the fastest moving thing in the universe? That we know about, of course? It's light. Its speed in a vacuum reaches 186,000 miles per second. If people could travel at such insane speeds, we would have already explored hundreds of new worlds which are inaccessible to us today because of how far they are located. Interestingly, while traveling at the speed of light, you would experience time differently. Your mass would become infinite, and you would slow down. That's because the faster an object moves, the more mass it has. That's why, in real life, traveling at the speed of light in the conventional way doesn't seem possible. Okay, another question. Could we slow down the speed of light? In 2015, a team of scientists from Scotland claimed they had found a way to do just that. They sent protons through a special mask, altering their shape. And in this malformed state, super tiny particles of light started traveling way more slowly than regular protons. It's true that the difference in speed was almost imperceptible, but the fact they had managed to do it was amazing. It means that the speed limit of light isn't as unchangeable as we thought before. It's another question why anyone would want to slow down light, as if it's not slow enough as it is. Ah, I see. This last statement might sound confusing, but let me explain. We humans are used to traveling at unhurried speeds of 60, 70 miles per hour on the highway. So to us, the speed of light seems to be unreachable. But how about this? If we reduce the observable universe to the size of our planet, crossing the Milky Way galaxy would be like walking a few houses down the block to visit your friend. And still, it would take a whopping 100,000 years if you traveled at the speed limit of this Earth-sized universe. This example shows how incredibly slow it would be for a spaceship to explore other worlds at the speed of light. Crossing our home galaxy would span more than 100 human generations. And even if we let humans be and concentrate on protons dashing across the solar system, the speed of light would still turn out to be too sluggish. Astronomers have calculated that it takes light almost as much as 45 minutes to travel the distance between the Sun and Jupiter. And it takes light 5 hours to reach Pluto. When you look up at the sky at night, you see stars as they were a long, long time ago in the past, thousands of years. That's how long it takes the light they emit to reach us. So now that we know that the speed of light is indeed pretty slow, we can try to find the answer to the main question. Why is it so? So far, the only answer astronomers have is because. A tiny bit more satisfying version of this answer sounds like this. The universe is designed in such a way that protons move with such velocity. There's no specific reason why it should be this way, it's just the way it is. As you see, the answer is a non-answer at the same time, and we're simply stuck in this slow universe. But would it be better if light was much faster? What would our lives look like if the speed of light was boosted by a factor of 1,000? Then, a spaceship moving at the speed of light could cross the Milky Way in less than a century. A trip to Alpha Centauri, the closest star to Earth other than the Sun, where potentially habitable planets may dwell, would take less than 2 days. Computers and different networks would function way faster due to enhanced optical speeds. But at the same time, the Sun would also become much hotter, around 1 million times hotter. And it would mean only one thing: Earth would be boiled in no time. So we should probably be grateful for our slow speed of light. If it were even a bit faster, our planet wouldn't exist.
You switch on the light as soon as you enter a room. You never even stop to think about counting how long it takes for the bulb to light up. You couldn't. It's as if it's instant. Well, technically you could if you were fast enough. Good luck clicking that stopwatch in time when you're measuring over 670 million miles per hour. That's 180,000 miles per second. Almost the distance from the Earth to the Moon in the snap of a finger. Oops, wrong sound effect. Can you give me a finger snap? Yeah, that's it. In the snap of a finger. And the Moon's further away than you probably think. If all the planets in the entire solar system were lined up in one epic conga line, they'd fit between the Earth and its satellite. And that's including poor outcasted Pluto. Okay, light is fast. Moving on. It's a beautiful sunny day, perfect for a jog. And like any other day you go for a run, you stop and think, hey, I wonder what the speed of sound is, don't you? Well, definitely not nearly as fast as light. Need proof? Check for yourself next time it storms in your area. You'll see lightning flash before hearing the crack of thunder. The light from that bolt rushed to you, zoomed into your eyeballs, and up into your brain for you to understand, oh, lightning. All the while, the sound wave from the thunder is still on its merry way to your ear. It'll get there, just give it time. By the way, thunder isn't the sound of storm clouds crashing together. It comes from that very same lightning bolt. It races toward the ground and rips a path through the air as it does. The air politely moves aside to make way for the lightning, and in the instant the lightning's gone, boom! The air comes back together and makes the sound we call thunder. Oh, and here's a fun fact. Sound travels faster underwater than in the air. A little over 4 times faster to be exact. So if you were to go for a swim with your friend and shout something bizarre underwater, they'd hear it a bit sooner than if you did the same thing outside of the pool. Uh-oh, everybody else heard it too. Oops. Sound also travels over longer distances underwater. It's why humpback whale calls can be heard for thousands and thousands of miles. But in a controlled environment where the air is dry and we have a constant temperature of 68 degrees Fahrenheit, the speed of sound is about 760 miles per hour. Now, that's a more realistic number, one that people can even reach. The famous Bell X-1 aircraft was the first to break the sound barrier on October 14, 1947. Test pilot Chuck Yeager was in the cockpit of the rocket plane. Imagine hearing that sonic boom for the first time ever in history. Bravo, Captain! Humans can race with sound, but light is a whole different challenge. For one, measuring it in the first place is no easy task. The official speed of light has changed several times throughout history, even going back to the 1600s. After centuries of debate and experiments with different results, the scientific community finally settled the matter in 1983. Maybe. To measure the speed of anything, you'll need to know 2 things: the distance between point A and B, and the time it takes for an object to travel between those points. With distance divided by time, you'll have yourself the speed of light. But with every experiment done to measure light speed, there's always been an extra cog in the wheel that everyone overlooked, or rather brushed aside. When doing an experiment using light beams and mirrors, we've always included the light beam's trip from A to B and back to A. With equal speed and equal distance, we have ourselves a controlled experiment and conclude an official speed number for the books. Case closed. Let's celebrate! Not so fast. A certain someone in 1905 had something to say about this, and that someone put a theory out there that light can travel different speeds going forward and back. Still can't wrap your head around it? Well, let's take this example. You had a long day. You pulled an all-nighter at work and can't wait to sink into your comfy warm bed. You get on a bus and head home. The night's clear and there's zero traffic on the road. Before the wheels on the bus can even go round and round, you immediately conk out in the back seat. But right before that, you checked the clock and saw it's exactly 10 p.m. What? After a big bump on the road jolts you awake, you become aware of your surroundings. But you suddenly find yourself in the exact same spot as the moment before you fell asleep. That was a quick nap. But then you look at your watch and it's now 11 p.m. You fell asleep in the bus and missed your stop. You'll have to repeat the exact same route all over again. Bummer. What can you determine from this? Since the whole ordeal took you an hour, you can assume it took exactly 30 minutes from the bus stop to reach your house and another half hour from your house back to the bus stop. Sounds logical, right? In our physical bodies, such a conclusion makes perfect sense. But it was Albert Einstein who challenged this idea. With his reasoning, the trip could have taken 59 minutes to get home instead of 30 and 1 minute back to the bus stop. Or even vice versa. Since you were fast asleep, there's no way you can know. And this idea is what's keeping scientists and physicists up all night throughout the decades. When you get into light speed in space, then the mind-blowing stuff starts happening. It takes approximately 8 minutes for light to reach Earth from the Sun. So, light is super slow in space? Not really. Now we're talking unimaginable distances. It takes 8 minutes for our Sun's light to travel over 90 million miles to our planet. That's something to think about when going to the beach. The sunlight that made your tan lines traveled so far across our solar system to reach your skin. Ah, how thoughtful. And you can get sunburnt even on a cloudy day. That's how powerful our star is. Now, imagine yourself living on Pluto. I know, its planet membership got revoked in 2006, but hey, call me old school. Our former furthest planet from the Sun is so far away, It takes 5.5 hours for sunlight to get there. No wonder it's always cold. The first planet in line is Mercury. The sun's rays reach it in a mere 3 minutes. Hey, that's probably enough time to listen to your favorite song. By the time the song ends, you, the Mercurian version of you, will be basking in the sun's glory. It'll be impossible to listen to that track in space since sound can't even travel out there. No one can hear you scream. Oops, there she is again. Music is just vibrating air, and without any air in space, sound can't travel. That explains why it's so eerily quiet out there. Okay, can somebody take the scream girl down the hall? And while we're up in space, let's pay our neighbor a little friendly visit. Alpha Centauri is the closest star system to our own. And what fun, the trip is just 4 light-years away. That's 25 trillion miles and 137,000 years on the road. Yeah, don't forget to pack a big lunch. To put all that in perspective, it would take around 5,000 generations in a super shuttle traveling through empty vast space to complete the journey, and we won't be able to come close to the star. Oh, and that's just one way. Okay, I think I'd rather come back to Earth now. Whew, that's better. Now, the longing question: how can we measure the speed of light without that little dilemma about the return trip? Oh, I got it. Why don't we just measure the speed with a super high-tech camera and map it out frame by frame until we're able to write down its speed? Well, nothing's as easy as it seems in the world of physics, because when filming the light through a lens, we're not seeing the light itself, but rather a reflection of it. We just circled back to square one. Okay, scratch that plan. Then how can we prove light is going the same speed to its destination as its reflection is back to point A? Does the one-way speed have a defined value that's not a constant? Well, this is the ultimate question among scientists, and so far, there's just no way of truly measuring it. Unlike the speed of sound, which is more conceivable, the speed of light might just be light years ahead of us. Yes, just more fun light facts brought to you by The Bright Side. See the tie-in? Okay, never mind.
Something's moving toward our planet that could end all life on Earth. It's a regular needle, weighing about 5 grams. You're probably wondering why it's so dangerous. Can something that small really do any harm? It's hard to say, because it's moving at the speed of light, and we don't really know what will happen when it hits. That's because the idea itself is hypothetical, so it leaves us with a bunch of questions. Here's the first one. What happens to a sewing needle in space? Could it actually accelerate to the speed of light? The short answer is no, but it's not that simple. In our universe, nothing that has mass can reach the speed of light. It takes energy to make any object go faster. Since there can't be an infinite amount of energy, nothing can ever accelerate that much. So in our case, we can simplify things. Let's say that the needle is moving at 99.9% of the speed of light. That's about 186,000 miles per second, or 670 million miles per hour. At this speed, the journey from the Earth to the Sun would take about 8 minutes. For comparison, the maximum speed of a Falcon Heavy rocket is 24,600 miles per hour. And the fastest car on Earth is more than 2 million times slower than the speed of light. The biggest rock to ever hit our planet was the Webb meteorite. It weighed about 60 tons. It fell to Earth around 80,000 years ago and caused a lot of damage. Would something as small as our sewing needle be able to have the same effect? Sure it would. It's all about the energy involved. Small things traveling at almost the speed of light would have more energy in them than really big but slow-moving objects. So our speedy needle would hit the ground much harder. On impact, all the energy it contained would cause a mighty big kaboom. Everything nearby would just disintegrate. But could such a big explosion really destroy our entire planet? Let's compare this to the biggest blast humans ever made. The cloud of debris that followed this explosion was 40 miles high. It could be seen from a distance of 100 miles. About 50 megatons of explosive force was released into the atmosphere. The energy our needle would release as an explosion would be about 43 kilotons of force. That's less than what humans can cause, but it could still lead to massive damage. So if you hear on the news that something is headed for Earth at the speed of light, you'll definitely need to find some cover. Could people survive a collision like this? Well, it would be pretty scary. A dazzling flash of light would be followed by a shock wave of incredible force. The glass in all houses within a 2.5-mile radius would be smashed. Even the strongest buildings would collapse. All that energy coming from our needle would cause seriously big fires up to 1.5 miles from the epicenter. Everything at this spot would essentially be vaporized. The situation would be a little different if the needle went into the ocean. Just like a meteorite, its impact would cause a huge tsunami, but the shockwave wouldn't affect big cities, and people probably wouldn't be hurt. Although if it hit off the east coast of the United States, this tiny object could still cause flooding in New York. But other things could happen if a needle like this entered the Earth's atmosphere. Because it's moving close to the speed of light, the needle won't actually be a solid object anymore, but more like a bunch of atoms flying alongside each other. So it's possible that the needle would just pass right through our planet, the same way it would cut through a balloon. It would happen very quickly, in a split second. No one would even notice, and people would just go about their business. But here's the most incredible possibility. What if the needle hit a person? Well, there's a very small chance of that happening, just 1 in 1.6 million. Although something similar happened at least once, when 2 men in Turkey experienced rain made of rocks in 1888. But let's get back to our needle going at light speed. If the human body completely absorbed all that energy upon impact, it would just disintegrate. But there's another possibility as well. The needle could weaken the bonds between molecules and atoms in your body and pass right through them without causing any pain. You'd just feel something like a mosquito bite. Of course, it would still leave its mark. The needle would make a perfect hole in your body, but so long as it didn't go through your vital organs, you'd be fine. Plus, you could boast about your incredible good luck. The chance of a space needle hitting you is almost like winning the lottery. So it seems a needle moving at light speed wouldn't do that much harm. It might create a big crater in one spot, but the world would be all right overall. But what if something much bigger than a needle flew towards Earth? In 2013, a large meteorite entered the atmosphere above Russia. Luckily, most of it burned up before it reached the ground, but the largest piece of it that survived weighed slightly over half a ton. The meteorite exploded about 14.5 miles above the surface and lightly damaged more than 7,000 buildings. About 1,500 people were injured, but it was only moving at about 37,000 miles per hour. What would happen if it had accelerated to close to the speed of light? An object this big, moving at a speed of nearly 186,000 miles per second, would have an enormous amount of energy. Its impact would basically wipe out an entire continent. The blast wave would have such force that it would completely circle the planet and pull down absolutely everything in its path. The tsunami caused by the explosion would wash our civilization into the ocean. Humans would only survive if they made it to very deep underground bunkers. But once the dust settled and we went back up to the surface, we would find that there was nothing alive left on Earth. It would be more or less the same as when a meteor destroyed the dinosaurs millions of years ago. It's true that that meteorite didn't move as fast, but it was just as big. Of course, our planet recovered from that impact, and life returned. There is actually an object moving around in our solar system right now that could destroy half the Earth, Halley's Comet. It weighs about 220 billion tons. That's a whole lot of zeros. By the way, this comet has come close enough for us to spot it at least 30 times. The last time it could be seen was in 1986, but we'll have a chance to see it again in the not-too-distant future. Its next appearance is predicted for July 2061. If an object like Halley's Comet hit the Earth at the speed of light, it would completely change the shape of our planet. The blast would form a crater the size of Eurasia. After a blow like that, the Earth would never be the same again. Now let's talk about something that's a little more real, although it's seriously weird. Is there anything out there in the universe that can move at the speed of light? Well, almost. Scientists have discovered that some superactive galaxies can spit out hot blobs of gas the size of Jupiter. These galaxies are called blazars. When they studied the blobs, the scientists scratched their heads in confusion because the speed of these things is about 99.9% the speed of light. To accelerate something as big as a bowling ball to that speed would take all the energy produced on Earth for an entire week. So imagine how much you'd need to fire off a Jupiter-sized lump into space. The chances are that these blobs are getting all that energy from supermassive black holes inside the blazars. The hole itself absorbs tons of particles, but also accelerates others and pushes them out into space. The speed of light is the fastest thing in our universe. It travels across space, passing through Mercury and Venus to reach us, and it's slowing down. No need to panic though. The sun is getting weaker, but we won't see the effects of it for another billion years. In the vacuum of space, the speed of light is around 186,280 miles per second. Any slower than that, and humans would see the changes firsthand. There would be some awesome effects, like colors changing and the brightness of objects fading. We'd also notice some differences in everyday objects, their length and shape. Scientists created a simulation to see what would happen if the speed of light was slower. In a vacuum, the speed of light can't change, but if light passes through different materials and objects, it alters the way we perceive things. Light acts as a wave and a particle, meaning that it's a wavelength. The color and frequency are determined by the distance from crest to crest in the wave. It behaves similar to sound with the Doppler effect. Imagine you're standing in the middle of a busy highway and a honking car speeds through. Wow, that was loud. You can hear that whoosh-like sound of the horn because the moving object produces the sound while you're stationary. The frequency and pitch seem to change, but it's just the sound reaching your ear faster than it would if you and the car were both stationary. Light behaves similarly. The wavelengths change if the speed changes. Moving toward a light source and making the wavelength shorter will shift the color to a blue and violet hue. Moving away from the light source, and you'll get something more reddish. So if the speed of light slowed down to walking speed, we'd notice the colors changing when we approach an illuminated object. At the same time, the color would change around us and behind us. If you walk sideways, the colors you're walking toward would become bluer, and everything in the distance would become red. This information is useful to astronomers who are studying objects in space. If they're blue shifted, that means the object is moving towards us. And if it's red shifted, then it's going in the opposite direction. In fact, everything in the universe is red shifted, proving that the universe is expanding and getting further away from us. The slower it gets, the brighter it becomes. That's because the photons become more present for us to see. At this rate, we can see invisible light and increased intensity. You won't notice that effect much if you're standing still, but because of the Doppler effect, moving towards an object will have different colors and different light intensities. Another phenomenon we'd experience is time dilation. It's when you move at a similar speed as light and time decreases relative to someone who isn't. Space and time are relative. So if you're sitting at your desk wasting hours away, yeah, sounds familiar, doesn't it? All your movement will go through time and not through space. You're stationary, but you're still technically moving forward in time, slowly aging. The faster you move through space, the slower your movement through time will be. If you move at the same speed as light, then all your movement will be through space and not through time. To notice that, you'd need another person to watch you. You're not in a time machine. You're both on Earth experiencing the same time flow. To you, experiencing this firsthand makes it feel like you're going faster because you're getting a lot more movement in space in a given time. The closer you get to the speed of light, the smaller you become. Well, not really, but it depends on who's watching. If you're the one traveling at such a speed, an object nearby will seem small, just as someone who's watching you travel at the speed of light will think that you're smaller than you actually are. The simulation that the MIT scientists conducted showed that if the speed of light drops, everything will become stretched out like a pancake. If you see mountains in the distance and then run at the speed of light, they will appear further away. Objects will become distorted, and it will feel like you're getting to a certain place faster because time has slowed down for you. If you're standing completely still, and someone standing on your left-hand side throws a cube-shaped object over to your right-hand side, then naturally, you'll see one side of it unless it flips around. But in this new reality, you'll get to see the front side wrapping around the visible side you're seeing. If you're moving at the same speed as light in an infinite space, everything will be stretched out as you reach infinite speeds. In a world where people can walk at the same speed as light, we'll perceive nothing as normal. We'll have to get used to the way we see objects. Every movement we make will result in drastic shifts of colors. Even turning your head to look at something will feel weird. Let's say you're in a supermarket buying groceries, and you walk from aisle to aisle. The milk at the end of the counter will look like it's really close to you. But when you approach it, you'll start to feel like it's getting further away from you. The milk will also look a bit red. As soon as you get closer to it, it will shift to blue. If someone is passing through with a shopping cart, you'll see it as a sort of 3D model of a shopping cart. The color will shift as it gets further away from you. It will appear far away, but it's right in front of you. In fact, we don't really know the actual speed of light. Physicists gave it roughly 186,280 miles per second, but that constant is just for them to calculate other scientific stuff so we can understand it better. The problem is that we can only measure light with light beams and mirrors. But it's not like all we have to do is point a light beam at a mirror and measure its original path and its reflected path. Einstein's theory of relativity states that the original path of light moving from the source to the mirror may not be the same speed as the reflected light from the mirror back to the source. Hypothetically, if it takes light 10 seconds to travel from the source to the mirror and then back to the source, then we can conclude that each trip takes 5 seconds. But Einstein's theory is that it could take 9 seconds for light to travel from the source to the mirror and only 1 second from the mirror back to the source. Or vice versa. Or maybe completely different numbers altogether. That's why it's so difficult to measure light. A breakthrough came out for scientists when they managed to slow down the speed of light to 0 without losing its brightness. They did this by using ultra-cold atom clouds made with photonic crystals. These crystals are materials punctured with billions of tiny holes where light can refract. But what if we lived in a world where light stopped halfway? You'd wake up one morning and feel like it's twilight. You'd open the curtains and see that many car lights are on, but aren't so bright. You turn on the lights in your room, but feel like the bulb is tapping out. You replace it with another one, but it doesn't do the trick. You turn on the lights everywhere in your house, but it's all just giving weak light. You're confused and try to check if there's a problem with the electricity in your house, but it seems to be working well. You check on your neighbors, and they also have the same problems. Even experts in the field can't understand what's going on. Hours pass, and it's all the same. All the light in the world seems to have frozen halfway. Your phone is low on brightness, even though you bumped it up to maximum. Everything is getting darker. You learn from the news that it's a global problem. Light is slowly diminishing, and soon there won't be any of it in the world. You decide to wait it out while everyone else is panicking.
Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why." Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kinda makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds, but around the equator you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be endangered, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around. probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry?
Let's head to the Middle East. There's a large desert here, and it's completely dark, except for one spot. It's a big circle that glows with a bright orange light, the Darvaza crater, and it's just a giant gas burner. Years ago, geologists found gas here, and they started mining for it. But when they excavated, they came across a void underground. The void collapsed, and it formed a crater. It's as wide as half a soccer field and as deep as a 5-story building. Gas began to come out of the cracks in the crater, and since animals were often grazing near this place, the geologists decided to set these gas streams on fire to exhaust the source. Geologists thought the fire would be over in a day or two, but if you come here now, you'll see this gateway to the underworld is still burning, and it's been going on for almost 50 years. In 2013, a man descended to the bottom of the burning crater for the first time. He collected many different samples there, and scientists were able to find bacteria that aren't found anywhere else on Earth. They're quite comfortable at the bottom of this endless burning frying pan. In 2009, a man in L'Aquila, Italy, saw flickering lights dancing above the stone street. He immediately knew what to do and moved his family to a safer place. Only seconds later, a massive 8.3 magnitude earthquake hit the whole region. His knowledge of the strange lights saved his and his family's lives. So, what are those mysterious warnings? For centuries, people interpreted the lights as something otherworldly. The scientific community didn't take them seriously, just put them down to a false recollection, a mind trick, or pure imagination. With the introduction of surveillance cameras and smartphones, the amount of evidence grew enormously. Now the connection was obvious. Lights appear and an earthquake hits. So, experts finally started taking it seriously and started digging for the truth. But after years of research, to this day, geologists are still not fully sure what the source of the lights is. But they have recognized 5 types of them. Bright flashes that light up the sky, looking like storm lightning or a strong camera flash. Rays in the sky that can look like light columns. Different sized flames that come through the ground. Diffused glows over the mountains. and slow-moving balls of light that can be misinterpreted as ball lightning. Another equally little understood atmospheric phenomenon. These are literal balls of lightning that can float and explode, leaving a sulfuric odor behind. But unlike ball lightning, these spherical EQLs seem to be harmless, if you don't count what's coming afterward. But with all these types of lights, experts can't know how exactly they're connected to earthquakes. They don't only show up before one hits. Some have been reported during and after earthquakes. They can also appear with other phenomena, like meteorite crashes, volcanic eruptions, or auroras. For now, scientists can only come up with theories to explain the unexplainable. One of the recent ones claimed the lights were electric lines being broken during an earthquake. But this theory doesn't explain how the phenomena was observed hundreds or even thousands of years ago. Like the ancient Chinese tale of dragon-looking clouds appearing in the sky as a warning of an upcoming quake. Or how an ancient Roman historian reported huge flame-like lights bursting out just before a huge earthquake occurred. The electric line theory was quickly dismissed. Another theory suggested it was escaping gas. During an earthquake, the underground rocks expand and shrink under pressure and heat. This opens and closes small spaces between them. Different gases make their way through these new openings. Radon, for example, can get released during seismic activity. It can ionize the air, making it electrically charged. But radon doesn't do it enough to create bright sparks of light. This theory is close, but doesn't quite hit the mark. One of the most accepted theories is that it might be from electricity traveling up from underground. When underground igneous rocks, ones that form from magma deep within the earth, are under stress, they release ionized, or electrically charged, oxygen. It travels through the surface and up into the atmosphere, where it creates a localized electric field. That can produce brief flashes of visible light. Some aren't even that quick, and can go on for minutes at a time. So, there you are. You've been driving for hours through the night. You didn't have any chance to sleep, so your mind is hanging by a thread. You stop the car and go out to stretch your limbs. And then, you look up into the sky and see a beautiful sunrise. Whoa, wait! There are 3 suns in the sky! You rub your eyes, but nope. There are still 3 bright stars in the sky. No, our home star hasn't been torn into 3 pieces, nor has it been visited by 2 other stars. This is called a sundog. It occurs mostly during severe frosts. Small ice crystals in the sky bend the light. As a result, you may see 3 bright spots in the sky instead of just 1. This phenomenon is officially called a halo. Usually, it's just a circle around the sun. You can even see a halo at night, too. Just look at a street lamp, and you'll see a bright circle around it. Sometimes, a halo can take on a fancier shape. If there's a lot of ice in the air, the light is warped even more, just like in a room with a dozen mirrors. Then, the halo can take on the shape of a human eye. Because of this phenomenon, a false dawn can occur too. While you're looking at the horizon, the dawn begins, and the edge of the sun appears. A little bit more, and wait, the sun starts to just dissolve in the sky. After a few moments, it's dark again. And only a minute later, the real sun shows its face. It was the same light curvature effect you saw before with the 3 suns. Only now, the light is curved vertically, not horizontally. And instead of the real sun, its reflection in ice crystals in the sky appeared. And now moving on. This cloud looks like a dinosaur, and this one looks like a cat. And this, whoa, it looks like these clouds are falling down. Oh, phew, that's just a mammatus cloud. Their shape really makes them look like chunks of cloud about to slam on the ground. Well, that's not going to happen, but you better start seeking cover anyway. Such clouds are a sign of a severe thunderstorm coming. It takes a lot of moist air with ice crystals at the top and dry air at the bottom to create such clouds. Then, vertical currents of air appear between these layers. And these currents make the clouds take the shape of a human brain. And this giant cloud looks like a dome that's going to cover an entire city. In fact, that's exactly what happens. A huge cloud covers a large area and then rains heavily on it. Sometimes, the front of such a cloud takes a bizarre shape, like in these pictures. It looks more like several giant spaghetti clouds, or even giant cloud worms. This phenomenon can often be seen in Australia, and it's called morning glory. It happens because a strong wind twists part of the cloud on both sides, and then the huge sheet of air dough splits into thick strips. And sometimes you can see clouds in the sky made of birds. Wow, that cloud moves quickly and changes shape. It becomes more transparent, but then denser and darker again. The birds seem to be involved in some kind of dance or performance, but they're not doing it for beauty or for the crowds of spectators gathered below. They're doing it for protection. When birds group themselves into such a cloud, they intimidate birds of prey. An eagle or hawk would have a hard time picking out a single target among the endless number of birds. And they move quickly, covering each other. Fish are huddled together in schools in the same way. Such a cloud might just spook a hungry predator. Grab some sunglasses and you're good to go. This phenomenon lasts around 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. Nature sends early signs of disasters in many different ways. J-shaped trees might mean there's a landslide coming. Since the ground is moving slowly, the trees grow into this super selfieable shape. Try to find a flat area and avoid going near any trees unless you have superhuman strength. Another mystical phenomenon can be seen in the desert, a sand waterfall. When the wind brings a lot of sand to the edge of the canyon, it begins to fall down. Now amplify this effect 100 times and you get a sand waterfall in Saudi Arabia. It's really like Niagara Falls, only there's not a drop of water. The locals say this phenomenon warns of an impending sandstorm.
There's a giant ghostly hand that stretches across space. Its eerie fingers are reaching for a glowing red cloud that looks like molten space lava. Although it looks like a scene straight out of a sci-fi movie, it's 100% real. The hand was formed after an enormous star collapsed in a huge supernova explosion. The boom created a new star that is bursting with energy. The energy given off by the star is so big that it caused debris from the explosion to swirl around it. This is what created the supernatural-looking hand. The hand is so big that it stretches a colossal 150 light-years. As for the lava-like structure it's reaching for, that's actually a huge gas cloud. So, while it looks spooky, it's completely harmless, and you can go to sleep tonight without worrying about a giant ghostly space hand scooping you out of bed. There's a bizarre star hidden in the depths of space that seems to randomly flash on and off. It's known as Tabby's star, and its light dims at super irregular intervals for really odd lengths of time. There have been so many theories about what's causing this, from meteor showers to outer space interference. The comet shower idea was quickly debunked. Dust from comets, which would block the light, goes away after a couple of months. Tabby's star fades slowly over decades, so the timing just doesn't add up. It can't be down to planets either, as no planet is big enough to block that much light from a star. After years of speculation, scientists have finally found an explanation for the strange phenomenon. The dimming and brightening are actually a result of space dust. A ring of dust surrounds the star, which often temporarily blocks its light. On day 8 of its mission in 2019, China's lunar rover discovered something really strange on the far side of our moon that caught the attention of the entire world. While navigating a path around a bunch of lunar craters, it spotted something really weird lurking inside one of the moon's holes. It was a colored substance, just like gel, that we'd never encountered before. The curious material was a rich dark green color and glistened like diamonds. After a year of analyzing the foreign substance that measured 20 inches by 6 inches, the scientists finally came to a conclusion. The glistening effect seems to come from glass. In space, it usually appears as a result of lunar impact melts. This means that it's most likely from a comet or rock that has hit the moon and melted upon impact. But while it's likely that the strange substance is just melted rock, scientists aren't 100% sure. This is because the pictures were captured under bad lighting conditions, and there were a bunch of other factors that badly impacted the quality of the images. So, the jury is still out on this one. There's a huge space cucumber floating through the galaxy, and no one really knows where it came from or why it's there. Okay, it's not exactly a cucumber, or a pickle. It's more likely a super elongated rock. Scientists think it may be longer than half a mile, but only 540 feet wide. It's traveling so quickly that there's no way it's bound by our sun's gravity, meaning that the strange object was formed somewhere outside of our solar system. We don't even know how long it's been wandering through space. It's estimated that it entered our solar system during the Victorian era, but who knows where it had traveled before that. For years, we've been told there are 8 planets in our solar system. 9 if you count Pluto, which got kicked out of the club some years ago. But that might all be about to change. There may be an enormous secret world lurking in the midst of our system, which scientists are calling Planet 9. This undiscovered planet could be way out past Neptune. There are seemingly unexplained clusters of orbits there, and this hidden 9th planet would explain this. The planet, if it exists, would be 10 times the size of Earth, take at least 10,000 years to orbit the Sun, and would sit over 200 times further out than our home planet. This is why it's been so tricky to identify, as it's almost impossible to take a picture of. In 2019, 30% of the area that the planet is likely to be in had been searched. It will take at least another 2 years to cover the remaining area. In the meantime, we'll be waiting on the edge of our seats. No. Strange radio waves are beaming down on Earth, and scientists are baffled. These fast radio bursts are sudden, unexplained, and last just milliseconds. We first picked up the weird signals in 2007, and scientists have been scratching their heads ever since. They appear to be coming from outside the Milky Way, millions of light years away. For us to pick them up from that far away, they must be emitting more energy in a fraction of a second than the Sun does in 80 years. Most of these signals only came once, which would have made identifying them much easier, until this all changed in 2017. In August, a signal was picked up that repeated 93 times, ruling out speculation that the signals were being caused by random one-off events. To this day, we still don't know what's causing the signals. Back in 2014, NASA captured a surprising picture of the Sun that showed that it might like to play dress-up. A brilliant storm of magnetic fields caused the Sun to look like a flaming jack-o'-lantern. Even weirder is that the image was captured on October 8th. It was possible because of something called active regions. These are basically areas of the Sun that have greater levels of light and energy. This is what gives the flaming look in the images. The light forms 2 eyes, a nose, and a wide, jagged, smiling mouth. Fortunately, this look was just a coincidence, and there isn't a giant pumpkin carving enthusiast lurking in the depths of space. Hey, I want to know, is this a trick or treat? Space fans spotted what appeared to look like a spoon on the surface of Mars. It was half covered in dust. They noticed it after images from a Mars rover had been released. As spooky as the suspicious silverware may sound, it was just a trick of the light. The spoon is just a regular old rock, albeit in a slightly odd shape. The play of shadows in the photo made the object look even more spoon-like. Maybe there's a dish nearby that the spoon ran away with. A cosmic eyeball floating somewhere among the stars is no regular-sized eye. It measures an incredible 660 miles across. One of Saturn's moons, Tethys, has become a bit of a celeb to space fans. The spherical moon sports a large crater that makes it look exactly like a giant interplanetary eyeball. There's even a set of peaks inside the crater that look like an iris. Saturn has a gang of 60 moons in total, and Tethys isn't the only one that looks like a random Earth object. Prometheus looks like a potato, Atlas resembles a pita bread freshly served from a Greek restaurant, and Mimas even looks like some villain's spacecraft. And then there's this. There's a giant cat's eye right in the middle of space. Its official name is NGC 6543, but that's kind of long and boring, so most people call it the Cat's Eye Nebula. And it's actually one of the first nebulas to have ever been discovered. Like other nebulas, it was formed by a star that shed its outer layer of gas. The gas floated off and produced this amazing and intriguing structure. The star fires off this layer of gas every 1,500 years. Each time it does this, it creates a spectacular new dust shell. Hey, don't get me started on gas.
Attention! Attention! Residents of all countries and cities of the world! A massive asteroid is approaching the Earth. Now its speed is several times greater than the speed of sound, and each day it accelerates even more. Once it enters our solar system, it will fly past Uranus, Saturn, Jupiter, and Mars. The gravitational fields of these planets will also accelerate the asteroid, and our planet will be the final destination. A collision is inevitable. According to scientists, a meteorite the size of Mount Everest can destroy the entire planet. The disaster will happen in 350 days. There's panic in the streets. People buy and build bunkers. Scientists and astronomers from all over the world were assembled to find a solution. The only way to avoid the collision is to destroy the space object. Yeah, a powerful rocket can split an asteroid into hundreds of thousands of pieces. In this case, a meteor shower will hit the Earth, but it's better than the complete destruction of our home. In less than a year, people build several powerful rockets. Then, using the best telescopes in the world, astronomers create a unique guidance system. And now, we just have to wait for the asteroid to get into our solar system. All the people start moving to one continent with top-notch bunkers for everyone. The damage from the asteroid is impossible to predict, so it's better to hide people in one super large safe place to wait out the collision. The moment has come. The asteroid passes by Uranus. The speed increases. Now the colossal space object moves only 10 times slower than the speed of light. Scientists launch rockets into the air. The asteroid flies past Saturn and destroys a part of its ring. The asteroid's trajectory is changing. It flies past other planets through a twisting path, picks up speed, and now heads towards the Earth. The rockets leave a long trail of fire behind and reach the speed of sound. They're getting closer to the asteroid. Near Mars, a collision happens. The rockets hit the target. The asteroid explodes and splits into millions of particles. All the pieces fly in different directions. The Earth is saved. At this moment, the Earth's satellites record a huge burst of energy. A small part of the asteroid is headed towards Earth. It's tiny, about the size of a grain of sand. But the explosion accelerated it, and now the grain of sand is flying towards the Earth at a speed of 185,000 miles per second, which is 99% of the speed of light. At this speed, the grain has almost the same destructive power that the entire asteroid had. It's approaching the moon. A few more seconds, and the grain of sand will hit our planet. All the people are waiting with bated breath. The grain gets such incredible power because of the laws of physics. The greater the speed any object is, the more mass and energy it has. When the grain of sand reaches a speed close to the speed of light, its energy and mass begin to increase dramatically. You can't even see this tiny grain of sand, but inside, it has the mass of an entire continent. If the grain reaches the speed of light, its mass will be infinite, and then a black hole will appear. In this case, all living and even inanimate things on the planet will disappear. Trees, seas, and oceans, all the cities, countries, and continents, air, sound, atmosphere, any molecule of the Earth, everything will be absorbed by the incredible gravitational force of the black hole. Then, when there is no trace of our planet, the hole will take over the moon. The gravitational force will grow and absorb other planets of the solar system. Soon, it will reach the sun. Our star will split into thousands of strips like spaghetti and will emit a tremendous amount of energy. This could trigger the birth of a second black hole, but fortunately, we only have 99% of the speed of light, which changes everything. Also, no object that has mass can reach the speed of light. The grain of sand enters the Earth's atmosphere. From the outside, it looks like a blinding meteor that pierces the sky. The grain heats up, passing through the layers of the atmosphere. Clouds within a radius of 100 miles around are burning up. The sky becomes crystal clear. If you look at it in slow motion, you can see the air is ionized because the air molecules are split. In nature, this process occurs during lightning flashes. Our sun also has ionizing energy and disinfects the air. The meteorite leaves an ozone hole behind it. So now, this place is not protected from space radiation and ultraviolet light. The grain of sand flies straight into the center of the Southern Ocean. The closest continent to the explosion is Antarctica. The air around it warms up and mixes with the cold temperature of the ocean, creating hurricanes. As soon as the grain approaches the ocean surface, the water starts boiling. The temperature and energy of the grain are so huge that the water evaporates, but the vapor molecules are instantly burned up. Thousands of gallons of water just disappeared from the face of the Earth. The grain flies down for the first few feet without touching the surface as the water evaporates before it. Then it falls into the ocean and creates a powerful explosion. Hundreds of millions of gallons of water foam and boil because of the hot temperature. The entire ocean within a radius of 100 miles is illuminated with a bright light. The ocean depths, where sunbeams have never been before, are almost as transparent as the water at the bottom of a pool. The wreckage of old sunken ships splits into atoms because of the powerful explosion. Unknown sea monsters and giant squids that live in the dark are afraid of the bright light and swim away. Then, finally, a grain of sand touches the seafloor and penetrates deep into the Earth's crust. If it reaches the Earth's core, the planet will most likely explode from a burst of incredible energy. Fortunately, this is not going to happen. The resistance of the ocean and the ground slows down the grain and takes its energy away. It provokes a slight shift of tectonic plates, and there's more to come. Huge waves form and spread throughout the ocean. The blast wave creates enormous tsunamis. Imagine throwing a small rock into a puddle. The same thing happens to the ocean. Huge waves are approaching the coastal cities. Fortunately, people were evacuated from there, but the damage caused by one grain of sand will cost hundreds of trillions of dollars. Houses are destroyed, roads are flooded. After a while, it starts raining with hurricanes. Ocean water vaporized by the grain forms into huge storm clouds. The wind drives them to the continents. And then, after the tsunami, prolonged rain begins, flooding entire countries. Several days later, natural disasters are still here. The temperature of the Southern Ocean has increased by several degrees. The water is boiling at the collision site, melting the Antarctica glaciers. Millions of icebergs are melting away, so the water level of the world's oceans is rising. The edges of some continents go underwater forever. Thunderclouds reach the Sahara and other deserts. The shift of tectonic plates causes earthquakes on some continents. Volcanoes are awakening. The sky is filled with volcanic ash. It will take months for all the ashes to settle. In the beginning, it creates challenging conditions for life on Earth. Plants and all living things don't receive enough sunlight. In trees and seaweed, photosynthesis is disrupted. Oxygen production stops. It's getting harder to breathe. The air that has filled the planet's atmosphere is slowly running out. People have to adapt to new conditions. They build new cities both on the land and in the ocean. They create plantations with artificial lighting for photosynthesis production. Fortunately, all the problems end when the ash settles. Inside the volcanoes, there's hot magma flowing. It may come in handy as it's rich in chemical elements and minerals. Together with the ash, nutrients fall to the ground, and the soil is now well fertilized. Plants, trees, fruits, and vegetables grow incredibly fast and produce a lot of new oxygen. The Sahara is filled with blooming flowers now, and it looks more like a meadow with flowers, not a desert. The grain of sand just renewed the planet instead of destroying it.